In this video, we're going to give an overview of O-Calc Pro. I'm going to be sharing with you each of the individual panes in the main view of O-Calc, and we'll give you a brief overview on how you work with each of these panes. And in future videos, we'll talk more about the use of each individual function and the most proficient way to perform tasks, including a brief look at some shortcuts for doing various operations. When you log into O-Calc, you'll see on the left-hand side at this home screen a master catalog. Now within the master catalog, you'll see subfolders. Within each of these subfolders, you'll be able to drag and drop equipment onto your structure that you'll see represented here in the 3D view and within the inventory. Within this catalog, you can build a pole beginning with any type of pole and then adding the regulations from the load cases folder. So what I'll do is demonstrate each of these. I'm going to go ahead and close the current pole that is opened, and we'll model here starting from the wood folder. We'll grab a 40-foot class 3 pole and we'll use a southern pine. As I drag that here to the inventory, you can see that it appears in the 3D view. Now I have a plus sign here in my inventory indicating I already have a load case associated with this pole, and you can see the resulting capacity results here in the bottom left-hand corner. If I delete this particular load case, come back here to the 2023 NESC, combined ice and wind, and I will select a grade C heavy load case and add that to the pole. Capacity meter will now respond with the new results for this 1/2 inch of radial ice and 4 pounds per square foot of wind, and the associated reduction in safety factor that is applied to the pole for compliance with the load case that I selected and added to this pole. Additionally, then I could build out one piece at a time, adding my crossarm, my insulators, my conductors, any applicable guying, any additional equipment. In this example, I'm going to choose the easy route here, and I'll come in here and choose a pre-built crossarm assembly, and then I'll drag and drop that to the pole. Now I can choose to take advantage of the preset height of 33, or I can customize the height myself, and in this case I will enter T-1, which is going to place this crossarm 1 foot down from the tip of the pole. Now here is my crossarm, and we can see this here in the 3D view. If I move my mouse left and right with a left click, then I can rotate around the structure. The mouse wheel allows me to zoom in and zoom out. A right click would allow me to orbit around the camera look point at the center of the 3D view. Now, additionally, if I hold my shift key down, I can use a rocking motion where I can view the structure from the top and from the bottom. There are many options for navigating in your 3D view, and those are going to be your basics. To return to the isometric view, if I click this reset button in the upper left hand corner, it will reposition the pole here. A bird's eye view then by clicking on the B will give me a top-down view of that structure. Additionally, I can use the spans 2x filter here to increase the rendering size of the conductors in the 3D view. This can make it easier for you to select an object within the 3D view. Additionally, if you had a very complex model, we offer the all types filter where you could eliminate different types of attachments and limit the scope of the data that you're seeing in 3D view. If I hit the expand button here in my inventory, I'm able to see everything that came across with that pre-built crossarm assembly. So I'm able to see each of my conductors. One of the features that O-Calc offers is the ability to substitute any of your conductors simply by dragging and dropping to the crossarm. Currently, I have the Acer 1/0 Raven. If we switch that out and choose a all aluminum alloy conductor Azusa, and I drag that over to the inventory, you notice the cursor is changed to a curved arrow, and that indicates that a substitution will be performed for everything attached to the crossarm. As soon as I click this yes button, you'll see a quick flash as it recalibrates, and now we see Azusa conductors on all of the pens. So quick, easy way to perform reconductoring. By the same token, that substitute feature in O-Calc, I'm holding my control key down and selecting each of these pens here in the inventory. By the same token, if you'd like to multi-select here in the 3D view, just hold your shift key down and be able to select all of those pens and say that I am selecting those for the purpose of substituting those for a larger size pen. If I want an 8.5-inch pen instead, just drag and drop over one of the blue highlighted areas here in the inventory, and O-Calc performs that substitution readily. We see our inventory, we see our pole here in the 3D view. We can continue to build this pole, and if I go here to my equipment folder, under transformers, if I decide to add a single phase transformer to the pole, I can do that. And again, I have options for setting the height, and if I choose to set that at 27 and hover my mouse over this transformer, midway we'll see we're at 27. So the connection point for this transformer from the catalog then is at midpoint. Let's talk about the 3D view. We're seeing a deflection path bar here indicating the movement that would take place with the pole given the current conditions that we see here with this load case, 4 pounds per square foot of wind and a 1/2 inch of radial ice on our conductors. So we're talking here about a wind speed of almost 40 miles per hour and radial ice on those conductors. We can continue to add to the pole under the equipment folder. Maybe we can add a street light. So we'll add that street light here to the pole and go ahead and set that height at the height you desire. And then if that needs to be rotated, we'll use the rotation feature here in the data entry to move that street light out as we wish. Now additionally, if I intended to have one of these conductors represent a neutral, then here in the span in the data entry, if I hold down my shift key, click on the word primary, it draws a blue box around both those fields, and I'm able to come in and quickly transition that to being identified as the neutral. Notice your neutral wire is gray then. Now, if I were to add a secondary, I could come here and select notice I'm hitting that collapse button to go ahead and zip those subfolders back up. And then it's quick and easy to navigate around. If I add my spool here, I'll go ahead and put that in at 24, and it has landed on the street side. If I wanted to transition that to the opposite side of the pole, I would select the field side, and you notice here that it did jump over to this side. So once I have it here, I'm able to add my conductor, and in the spans folder, we do offer some secondaries here in the folder, and I can choose from a quadruplex, triplex, or duplex. As I drag and drop to the spool, O-Calc adds that conductor for me in the opposite direction at 200 feet long. I can always change that. I want to have this run tangent, then I will drag and drop from wherever I find it here in the catalog or here in the inventory. So as I transition that up to the spool by drag and drop, then the secondary wire is now added to the pole. So additionally, I could add a secondary service drop, but we'll jump over here to communication. We do have in the assemblies folder some pre-built communication bundles for you. That is designed to make life a little bit easier for the user. The hardware is included with these bundles, so it makes it a very simple drag and drop. I'll select this 1/2 inch cable TV, strand and add that to the pole. I can enter my height, and then additionally I could add a telco bundle. I'll grab this 1-inch telco and I will set that a foot below. And then lastly, if I had a fiber optic, I'll take this 1-inch fiber optic bundle and we'll set that in at 16. So you probably have noticed the capacity meter is steadily rising here as we're adding to our load here in the 3D view. I can, now that I have my model completed, come to the top view, utilize the G button here in the 3D view, which brings up my gang editor and allows me to quickly and easily edit all of the spans in one direction, and say my adjacent pole is sitting at 220 feet. Now I will adjust the other side of the pole by clicking on the corresponding G here in 180 degrees, and we'll go ahead and modify the length here to 225. So my capacity meter is steadily rising as I lengthen the conductors. Again, if I expand here in the inventory, I can see everything that was brought over in those communication bundles. So I have my 1/2-inch cable TV, and then here we have our 1-inch telco and our 1-inch fiber optic bundle. The 7th panel inside O-Calc is here on the right-hand side. This schematic view that I have just pinned to my desktop is going to give me a quick at-a-glance look at my attachment heights, so I can quickly look through, see if I have any clearance violations on the pole I need to be aware of. But basically my pole model is complete at this point. Now additionally, in the measure tab, I could have brought some images over, and this is very common practice in O-Calc to bring in some images of the structure, calibrate that CVT, that white 13-foot telescoping fiberglass pole that we attach to the structure, step back and take a picture. Once these red reflective bands, these 4 points, are calibrated, then O-Calc is able to tell me the set depth of the pole from the image and the height of all the attachments. I can also get some conductor diameter measurements, which is really helpful for my communication bundles, and angle measurements, as well as arbitrary measurements for the size of some of the insulators or equipment. This measure capability, we call the digital measurement technology inside O-Calc, is standard practice here at Osmose, and we find it to be quite helpful. So that concludes our overview of O-Calc Pro.